You can turn it off. That's fine for now. Are you guys okay with that? You, somebody get up, Eric.
So you guys all have the lights off.
I know.
You sit next to the lights in a lot of the classes.
Okay. Can we all see our papers good enough that this will be good?
It's closest to the door.
All right. Am I recording right now? I am. This is ridiculous. Okay, let's get going. Okay. So here we're showing one side equals the other. So we just start with the one side, which I'm going to start with the tangent. And this is similar to what you had on your quiz. It's just, it was cotangent instead of tangent and tangent. So anyway, whatever. So what you want to do is you're going to split it up so that both of these are both being divided by tangents. So I'm going to actually physically divide them both separately by tangent. Now, a lot of you did this. Some of you like magically got to the answer afterwards. Part of your proof here is not that you know how to get there, but that you show people how to get there. So you want to do more than just say, here's the answer. You want to show why. So don't be skipping steps. This isn't a I'm smart enough to skip a steps thing. This is a I need to show everybody else how to make it.
I was like, I'm not smart enough to know what stuff goes here.
So I split them up. Now, tangent over tangent, that cancels out to be 1. And then this other one, I have a cotangent over tangent. That's the same thing as saying I have cotangent times 1 over tangent. And 1 over tangent is cotangent. So now I have a cotangent times cotangent. So then I have 1 plus cotangent squared, which is the identity cosecant squared from the Pythagorean identities. Okay? Any questions on that? All right, next one then. So one of my big hints to you guys is change things into sine and cosine. So I'm starting with cosecant and tangent. I'm going to change cosecant into 1 over sine and tangent into sine over cosine. So really, when in doubt, if there's not any obvious math to do, I would change things into sine and cosine. Now, hopefully you all see it. The sines are going to cancel out. So then we have 1 over cosine, which is secant. It wasn't too bad if you know to turn it into sine and cosine.
Not do the box?
When you're not doing proofs.
Okay. Wait, with the sine and sine over cosine over there, that's the tangent on the other side, but you didn't.
So cosecant is 1 over sine.
Yeah.
Tangent is sine over cosine.
Okay.
Oh, so you just
For some reason I thought you
I
were
replaced
dividing.
cosecant with what it can be replaced with.
Okay.
They're being multiplied. Questions? All right, next one. So here we have the point 12, negative 5. So let's say this is 12 and here's negative 5. So here's our point. We draw in the triangle. We always go to the x-axis. So this side is negative 5, this side is 12. We do the Pythagorean Theorem to get our hypotenuse. Now on the picture it said, hey look, here's your angle. But don't forget, we're technically going to use this as our angle. We call it our reference angle. So then, if we go through and find sine of the angle is opposite over hypotenuse. So then cosecant is going to be the reciprocal. And I'm going to be checking positives and negatives, so make sure you do that correctly. Cosine is adjacent over hypotenuse, and secant's the reciprocal. Tangent is opposite over adjacent, and cotangent is the reciprocal. If we look at the other one, we've got negative 8 and negative 15. So once again, I draw in my triangle. This side's -8, this side's -15. If we do the Pythagorean Theorem, someone want to help me out with that? Said 17? Okay. So then, sine is the opposite over the hypotenuse. Cosecant is the reciprocal. Do I need to keep going on this part, or are we good? Okay.
It doesn't matter that the angle is the whole thing.
Nope, that's the whole point of reference angles. So this is all the angle right here, but we're using, that's the whole point of doing the triangle, is that reference triangle, this reference angle, is going to give us the same thing as what theta would. Okay, and then on page 150, number 63, it says a guy wire is stretched from the top of a 200-foot broadcasting tower. I have no idea what those look like, so that's what it looks like. So 200 foot. And we have a guide wire, so that's going down to the ground.
It's like an alien abduction.
I was thinking more of like the Seattle thingy that spins. Yep, that one. Okay, so anyway, let's see here. A 58-degree angle. My dad, when he was younger, one of his jobs, because he did like many things because he's bored, was to climb up these towers and replace the lights in them. Think about that. How scary is that?
That'd be kind of cool.
That was his job. Anyway, so 58 degrees there. This is actually what I find to be the hardest part of an entire problem, is drawing the picture. And you're going to have to draw the picture. Okay, so you want to think, remember when we talked about angle of elevation from the horizontal, angle of depression from the horizontal. I cannot say that enough. Angle of elevation, angle of depression is always from the horizontal. Okay, don't try and label this guy, don't try and label this guy. It's always the one from the horizontal. Okay, so getting that picture right is the biggest one. So you gotta imagine what's happening with it while you're drawing it out. Okay, how long is the wire? So we're trying to figure out x there, right? And then the other one, we want to figure out that one. So they gave us two problems basically here. So again, one of the biggest questions you guys ask is, what are we using? Well, we know this side and we're trying to find the hypotenuse. So we know the opposite and we're trying to find the hypotenuse. That is sine. So sine of the angle equals the opposite over the hypotenuse. And once you know, once you have that set up, you have to get x out of the denominator. So I'm going to multiply both sides by x. So now we have x sine of 50 degrees equals, the x's cancel out, 200. And then we have to get the sine of 58 degrees, thank you. We have to get rid of the sine of 58 degrees.
It's like a blue mark on the blue.
It's not good color. Okay, I will switch. So then we have x equals 200 divided by the sine of 58 degrees. And just make sure your calculator is in degrees when you do this. Okay? It's actually not a blue background, it's a black background. My light bulb makes it. The light bulb's going out, and until it actually goes out, they won't replace it. It was going out at the beginning of last year, so I understand. They last a long time even when they're going out. So, okay.
You just break off her.
Yeah.
Reach in there and touch it.
So the other thing is that they wanted us to find y. So if we know the opposite and the adjacent, we're talking about tangent. So tangent of 58 degrees equals the opposite over the adjacent. And then it's just going through the same math. Only with tangent. Oh, at that point you could, I suppose. If you know two sides, so if you know this side and you found this side, you could use the Pythagorean theorem to find this one. Of course, that would also go back to the use what you're told versus use what you found out and hope is right, right? If we use the Pythagorean theorem at this point, we hope we were right, because then that'll make that right. But if we weren't right, this will automatically be wrong. So this might be a better, if you're really trying to make sure you're right. Okay.